Alright guys, welcome to Algebra 2. This is 212. This is actually the first day of a 2-day lesson. So the first day is going to be a little bit more exploratory. So what you're going to want to do is we're going to do problem 11, and I'm going to have you guys do parts A and B on paper. Then I'm going to ask you to use a graphing calculator on C and D. Go ahead and use Desmos for that. That's going to work just fine for us. So I'm going to have you guys pause the video, read through that, try and do all of that as you can, and then once you've kind of done it, come back here and I will go through kind of these problems and what you should have been able to kind of observe while doing it. So go ahead and pause and come back. Okay, so if you take a look at our Desmos screen, the first thing that we're going to be wanting to do here is graph the equation, which it gives us, which is y is equal to x minus 2 times x minus 2. Right. So things that I notice about this, well, I have this vertex at 2, and I see a little y-axis here at 0.04. It asks you about, hey, where would the axis of symmetry be? I'm not going to be a huge stickler on that because it's fairly obvious. As long as you can kind of point out and say, hey, it's right there, it would be here at x equals 2. That would be our axis of symmetry for the parabola. It's important, but not necessarily as much for what we're going to be doing today. So I'm not going to stress those as much. So the next thing that it asks us to do is, all right, we're trying to find equations of two parabolas with different graphs that also open upward and still have a vertex at 2, 0. So what you hopefully found as a way to do that was if I take the same equation, I'll leave that red one there as a point of reference. If I multiply on the outside of it, like let's say I put a 2 here, right? Now my green graph is different, right? I could also make it a 3, I could make it a 5, I could make it a 0.1, right? You can multiply anything on that outside and it's going to have that same vertex, but it's going to be a different graph. Now if I do any kind of changes on the inside, I'm getting these shifts. I change that 2 to a 3, moving over there more. So I really don't want to be messing with that stuff there. And if I do, like say, trying to add stuff, like say +3 on it, I'm going to move it up or down. If I do like a -2, so those aren't going to work either. So really the only thing that I can do to change that is multiply it by some constant, like 7 or 0.05, whatever we want to do there. Okay? So anything there would kind of work. Now, the next problem that it asks us to take a look at is use your graphing calculator to find equations of two different parabolas that open downward, each with its vertex on the x-axis at 2. How did you change the equations to make it open downward? So what you should notice there, if I want it to go down, if I put a negative in front of it, now I'm going to be going downward. And if I put like a -2, it's still going to do that change on the graph shape, but now it's still going down because of that negative in front. So again, anything with a negative there, and then any variety of numbers, we can get a bunch of different graphs doing that. So hopefully that's what you found as far as that portion goes. And then we go down to D. Use your graphing calculator to find the equation of a parabola that opens downward with a vertex at -4, 0. All right, so this is where it's going to be a little bit different. So we're going to have to actually change where the vertex is at. So let's hop back over here. And what I'm noticing here is on these ones, 2 is my important number here, and I see a 2 here and a 2 here. Well, what if I make this like a 3 and a 3? Well, my vertex is now over here at 3. Right? So if I want my vertex at -4, well, I should change that 3 to a -4. And I can change this 3 to a -4. Right? And lo and behold, hey, puts it here at -4. Now, this is kind of ugly over here, right? This minus a -4. We can really change this to being just a +4, right? So let's just go ahead and do that. That's going to be the kind of way that you're actually going to be seeing it. So I'm going to go ahead and do that for us. And now we're over here at -4. So the thing that I want you to hopefully notice here is that we have the kind of opposite signs here. If I have x +4, I'm going to go here at -4 on my axis. The -2, I'm here at +2 on my axis. So that's a pretty important distinction which we want to make. That's also a thing that people very easily get mixed up because because you see -2, say, oh hey, it's going to be at -2, where it's actually at +2, and vice versa. So there we go. So on that one, I have that, and then, oops, I can also see if I want to get different equations for it, I can just go here and put numbers in front, and I'll get the same vertex. And I can open it downward with a negative. I can make it wider or skinnier by changing the numbers in front of it, and stuff like that. So hopefully you encountered that portion as well. And then part E here says choose a new point on the x-axis and find at least 3 equations of parabolas that touch the x-axis only at that one point. So kind of, hey, try it again, but pick your own number. So we've done -2, we've done 4. How about I'm going to do +6. So if I want a +6, I need a -6 in here. I need it over here as well, -6. So then we're there at +6. And I can change it any way that I want by putting negatives in front of it, by putting numbers in front of it, however we want to do that. Okay. Hopefully this feels a little bit like, yeah, we kind of get it. If you're at the point where you're kind of bored with this, good. That's where we kind of want to be. This should be not terribly challenging stuff for us. The last thing that I do want to point out is we typically are not going to write it like this, because it's a little bit time consuming to write the same thing twice. We will typically see it as y is equal to x minus 6 to the second power. Because second power, all it means is, hey, it's that same thing times itself. So I can really write this as this. And this is how you're going to see it way more often. Especially if these were different, like x minus 6 and x plus 4, then we wouldn't write it because we couldn't. But whenever they are the same, we're going to see it kind of in that format there. So the last thing that I really wanted to kind of point out, so, oops, let me go back over here, there we go. For our closure, try and think about the equations you came up with. How did you get all of those things? So the first one, well, if I wanted to change that x-intercept where that vertex was, I could change that number inside of my parentheses. If it was a -2, then I was at +2. If it was like -4, then if it was +4 on the inside, then I was over at -4 on my axis. So kind of keep that in mind. And then if I wanted to have it flipped up and down, I could put that negative in front of it, and then putting also the numbers in front kind of made it wider or narrower depending on what numbers I was putting there. So if you're kind of seeing those patterns, you're in the right spot. We're going to, again, explore this more in the future. But with that, here is our assignment for day 1, 16 through 22. So go ahead and work on these, and I'll talk to you guys next time.